All right, hello everybody. Welcome to the new filming location, aka my classroom. Let's jump right into it. Another physics video lecture. Today, we're going to be talking about velocity graphs. All right. So if we remember from last class, so far we've been talking about constant velocities. Right? A constant velocity does not change, meaning the object's speed does not change, and it means that the object's direction does not change. So far we have been talking about objects moving in a straight line, going the same speed the entire time, okay? An example of this would be cruise control on a car moving in a straight line, right? And this is the equation we've been using. Velocity equals displacement divided by the time, meters divided by seconds, right? So if I wanted to know how fast this particular object is moving, we've seen this a bunch. Hopefully this is really easy. All we have to do is find the slope, right? So if I was going to find the slope of this line here, I would pick 2 points. I'm going to pick this point and this point. Point number 1, point number 2. I make my chart here. I have my first point, my second point. I have an x and a y value. My first point's always on the left-hand side, and this point is 0x, 0y. My y value, my x value for number 2 is 2, and my y value is 20. So my slope always equals rise over run, 2 minus 1. I plug my numbers in. Y2 is 20, minus y1 is 0, divided by x2 is 2, minus x1 is 0. And that gives me 20 minus 0, which is 20, divided by 2 minus 0, which is 2. I know it's kind of squeezed over there. And if you put that in a calculator, you know that 20 divided by 2 gives me 10, right? This is a velocity. That's what I'm trying to find, which means it's y divided by x, which is meters divided by seconds, okay? So we've done this. You guys can do this. You guys are doing great at this, all right? But what I want you guys to see now is that so far we've only looked at one type of graph. So far, all we've been looking at are position versus time graphs. And today we're going to introduce a new type of time graph, okay? This is called a velocity time graph. And what I want you to see is that these two graphs are telling me the same thing, okay? This one has position on the y-axis, okay, and time on the x, which means the slope of this line is my velocity. Well, this graph has velocity now, meters per second on the y-axis, okay? So this is showing me the same thing this is showing me. It's showing me a constant velocity. And look, that velocity is exactly what we found. It's 10 meters per second the entire time. This one's showing me the same thing. We have 5 seconds, and this slope is 10 meters per second. That's what we just found. This graph is showing me that the velocity is 10 meters per second the entire time. Okay? Give that a second to sink in. Okay? Something that I will say, now that we have more than one type of graph, is the first thing that you should do whenever you see a graph is look at the y-axis. This is what you want to check first. Your x-axis in this class is almost always going to be time. We're always looking at time and what's changing as time moves forward. So time's always ticking towards the right, okay? A position graph and a velocity graph are very different, okay? So I can tell you one of the mistakes people will make is you're so used to seeing a flat line and going, oh, the object's not moving. Well, look at it. Its velocity is 10, okay? It's moving at 10 meters per second. And if you are moving 10 meters per second, you're moving. All right. So here, I just wanted to break this down and show you that velocity graphs have a little more nuance, okay? We really have to see what we're looking at here. So here, on a velocity versus time graph, here we have velocity, again, on the y-axis, time on the x. So if the line is going up, if we have a positive slope, what that means is our velocity is going from 0 up to 20. We have what is called an increasing velocity, okay? Our velocity, we're speeding up, okay? Here, the line is flat. This is not 0 velocity. This is 20 meters per second. In fact, from A to B, this is when the object is moving the fastest. This one is when its velocity is the highest, right? It's the highest up. A flat line on a velocity graph means that we have a constant velocity, okay? And here, we have a negative slope, which shows me that that the velocity is going from 20 back down to 0, which means we have a decreasing velocity, okay? Here, the object is speeding up. Here, it's moving at a constant velocity, and here, it's decreasing its velocity, and when it gets back to 0, it stops. Now, this next one I'm going to show you is going to look a little complicated at first, but I'm going to break this down. Don't worry about this. I wanted you to see all of it, okay? I probably could have animated it a little bit, but don't worry. All right, so here's what we have. Here, we're starting, again, velocity is on the y-axis, even though I know I shot that line through it. So here's what we have. We start at 0 velocity. And the trick here, and I put it right here, if the line moves away from 0, that means your velocity is increasing, okay? If your velocity is moving away from 0, that means you are speeding up. If the line moves towards 0, that means your velocity is going towards 0, and it means you're slowing down, okay? And if your velocity is 0, you stop. So let's look at what's happening here. So we're starting, this is 0, right? So we start at 0 meters per second, and the line is going up all the way to 60, it's actually meters per minute, whatever, meters per second. This is an increasing velocity, okay? Our object is speeding up. Here, the object is moving at 60 meters per second the whole time. It's not increasing or decreasing, which means we have a constant velocity, okay? Now, this is the important part. The line is going down here. So here, we're going from 60 back down to 0, okay? That means that our velocity is decreasing. We're going slower and slower and slower, but guess what? Eventually, we get to 0. And if your velocity is equal to 0, you are not moving.
Staff, if you have A-Day morning duty, I sent an email last night before I left campus for you guys to be down at Bo Bison at 8:15. Let's make that no later than 8:20. Again, A-Day morning duty. We do have the 9th graders M through Z coming in. This is their first day for face-to-face, so we all need to be down there shortly.
There we go. Okay, hopefully no more interruptions, okay? When the velocity gets to 0, okay, that means that you are not moving. If your velocity is 0, you're stopped, okay? Now, here's what I mean that if the line moves away from 0, your velocity is increasing. Once we go past this 0 mark, here, this line is moving away from 0, okay? That means that here you have an increasing velocity, okay? Okay? Going backwards. Meaning, here you move forwards, your velocity was increasing. You have a constant velocity, this is where you're going the fastest. Now you're slowing down, slowing down, slowing down, slowing down. You stop. Now you're speeding up, going backwards in the opposite direction, right? Because you're moving away from 0. You're going from 0 to -5, -20, -30, -40. You're speeding up. You're just going backwards. And here, when we go from -40 back to 0, again, the line moves towards 0, which means that your velocity is decreasing, okay? Moving backwards, okay? These two are both going backwards. Okay? All of this is online. You have this, all right? We're going to look at a few more examples, but I like this one because it's kind of got everything in it. And I know it looks a little complicated, but if you just take a second to read it and remember these two things. What is the line doing? If it's going away from 0, your velocity is speeding up. And if it's going towards 0, you're obviously slowing down. When your velocity is 0, here, here, and here, you are not moving. That's 3 times that you're not moving. So a big thing that we have to be able to do in this class is we have to be able to take a position versus time graph and turn it into a velocity versus time graph, okay? So what that means is what we're going to do is just like those first 2 graphs. If we find the slope of this line, that becomes the velocity of this line, all right? Let me show you what this means. And we're just going to be talking, we're not going to be using numbers really today. We're just going to be talking about positives, negatives, and 0 velocities, all right? So let's look at this. Here's my position versus time graph. Here, for this first second, okay, our line is flat. That means that the object's position is not changing, which means it's not moving, which means its velocity is 0. So for this time, we have a 0 velocity, okay? From here to here, our line is moving up, which means we have a positive slope. The positive slope of a position graph means I have a positive velocity, okay? So here is 0. That means my velocity is going to be constant, and it's going to be above 0, right? This is a positive velocity. And again, if we found the slope, we'd find it was 0.5. Okay? Now here, we have another flat line. And in a position graph, that means our position doesn't change, which means we're not moving. So back down here, our velocity for that time, boom, is 0. Now here, our line is moving down. That means that we have a negative slope, which means we have a negative velocity. So in our velocity graph, that means that our line, there's 0, we're going to have a velocity below 0. Okay? But notice, all these lines are straight, which means that all of these velocities are constant, which is why we have these nice straight lines here. The slope of this line is -1, all right? Okay? So the slope of this line is -1. That means that the entire time from here to here, from, 7 seconds to 12 seconds, our velocity is -1. So from 7 seconds to 12 seconds, your velocity is -1. From 12 to 13, another flat line, means our position doesn't change, which means we got another 0 velocity, we're not moving. We have another positive slope, okay? This time that positive slope is the fastest of all the slopes because it's the steepest. It looks like it's about 1.75. And again, it's a flat line, which means it's a constant velocity. And then we have a slightly less steep slope, but it's still flat and it's still going up, which means from 16 to 21 seconds, we have a different positive velocity, right? It's easier to see that if I erase these. Right, this one's steeper, this one's a little shallower, which means this one's faster, and this one's slower. And that's it. These 2 graphs show the same thing. Again, it's all about reading. You got to see what's on the y-axis. What are you looking at? Is it a position graph or is it a velocity graph? This shows where the object is. This shows how fast it's moving. Okay. So let's do a couple examples of these together. Okay, so here I have 4 lines, and we can very easily look at them like this. This first one, this is a position graph. That means that this slope right here is 0. So this is definitely a 0. This is 0 meters per second, right? This line is going up, which means we're going to have a positive slope. And I can tell you real fast that we have rise over run here. So we're going to go from 20 up to 40, okay? And then we're going to go, so our rise here is going to be 20. And our run goes from 1 to 2, which is 1 second. Which means our slope of this line is 20 divided by 1. This is positive 20 meters per second. This is 0 meters per second. This is also flat, which means it's not moving. Here, let's do them individually. So our first line, we have 1, 2, 3, 4, 5 seconds. From 0 to 1 second, my velocity is 0, which means I have a straight line right there. My velocity is 0. Okay? Here, I have a positive velocity. In fact, it's a positive 20 velocity. So from 1 second to 3 seconds, I'm going to have a positive velocity from 1 second, 3 seconds, and it's 20. Which realistically today, I'm not too worried about, but why not find the slope, right? Here, we have no change in position. We started 60, we ended 60. You can do the math, but I'm telling you that that is 0 meters per second. So that's from 3 seconds until 3.5 seconds. We have a 0 velocity. And now, I know that this is going to be negative because we're going down. I actually think it ends up being like negative 27 meters per second. But the important thing here is to see that it's negative, which means our velocity is going to be below this line, which means for 3.5 to 5 seconds here, from here to, oh, did I go too far? That's okay. From here to here, we have a negative velocity. And sometimes I like to connect these dots, or these lines with dots. These two graphs are identical. Okay? Rough. Let's do another one. Okay, same one we saw last time, okay? We're starting out. Our position goes from here to here, maybe positive slope. Let's make this easy. That means, here, what do we have here? I have 10, 20, 30, 40, 50. I'm gonna mark my times. Because the time values are the same. We're looking at the same time, just different viewpoints. So here we have a positive slope, which means I'm going to have a positive velocity from 0 seconds to 10 seconds. Okay? We can calculate it, but again, I just want you to see it. Okay? Here we have a flat line, which means we have 0 slope. So from 10 to 15, we have a 0 slope. Here I have a negative slope going all the way down. Okay? In fact, I could calculate this. This goes from 0 to 60 and from 0 to 10, so this is actually going to be 6 meters per second. Here, this is 0. Here, we're going down. We're going from 60 all the way down to negative 40, okay? And we're going from 15 to 40, which is 25. So this is actually 100 divided by 25, or negative 100, which gives us negative 4. Okay. Again, I would highly recommend that you stop the video and go ahead and calculate these slopes with me so you can find this, all right? We're going from negative 4 all the way to 40 seconds. All of that is negative. It's all one straight line. Remember, this is a position graph, okay? And then we have a positive slope again, which means we're speeding up. We have a positive velocity going from 40 to 55 here, and we're going up 15, which is some sort of positive number. I forget it off the top of my head. But it's positive, and I think it's less than 6. Okay? Pretty easy? Okay. And we're gonna do one more. Okay, so there's a lot going on this one. All right, we started 0, we ended 0. We have 5, 10, 15, 20. All right, here we go. 0 to 2, 1, 2, we got a 0 velocity. Here, our line is going down. That means we're moving backwards, which means we have a negative velocity. So from 3 to 5, we have a negative velocity. So from here to here, boom. And in fact, that would be, let's see here, we go down 3 and over 5. So that would actually be negative 3/5. Oh no, sorry, negative 3 divided by 3 in negative 1. All right. Down 3 over 3. Negative 3 divided by 3 is 1. Now we're going from 5 up to 7, and we're going from negative 3 to 2. Okay, so that would be positive 2.5 from here to 7. Now we have a flat line from 7 all the way into like 12 and 12. So that is a 0 velocity, right? We're not moving. Now we're going backwards again, which means we have a negative velocity. And now we're going from 2 all the way down to negative 6. That means we're going down 2 plus 6 is 8. And we're going from 12 seconds to 13 seconds. So that's negative 8 divided by 2, which is way down here. I'm just gonna put it there, just make it a little easier to see. This is now -4. Then we're going up, okay, from -6 to 3 divided by 2, which would be 1.5, positive 1.5, which goes right here. We have a flat line from 17 to 18 right here, that's 0. Or sorry, from 16 to 18, 0. And then our last line goes from, actually there's 2, this one is just a wee bit positive. We go from -2 to 0, we go up 2 over 1. So this one is going to be 2. And then our last one is flat. It's just that last little one right there is 0. And again, you can connect all of these together with dots. Sometimes you'll see them connected with lines. This one is obviously pretty complicated, right? This is a big dog graph right here. That's what this is. But don't let that discourage you. All you have to do is find the slopes of the lines, which I know there's a lot of them, so I didn't calculate them all individually. But again, you look at the rise over run, you calculate the slope, and you put it on the graph. I know that's not the prettiest thing in the world, all right? So try to make these look a little bit better than I did. My apologies. If the line is above 0, it's a positive velocity, okay? And if it's moving forward, if the line is below 0, it's a negative velocity. It's going backwards, okay? And if it's on 0, it's a 0 velocity. It's not moving. All right, guys, I'm gonna stop here for today, all right? Make sure that you copy down all these graphs, all these notes. If you have any questions, email me or find me during my Zoom tutoring. I hope you guys are good. You can definitely do this. Go back, watch it from the beginning. Make sure you write down all the notes, copy down these graphs. If you can print them out, that'd be amazing. But if you can't, just take a second. Trust me on this. If you draw these down, make them look nice, like nicer than this, you'll do great, okay? All right, be good, guys.